Hey, welcome to the start of chapter 5. That means we've made it pretty far this school year already. Chapter 5 notes. Do you have them out? Are you looking at them? It says the learning target to find the least common multiple. So we probably should review this word multiple if we're going to do the least common multiple. So, very top of your notes, a multiple of a number is the product of that number and any non-zero whole number. Pause if you would like. So what does that mean? Multiples of 6 means 6 times 1, 6 times 2, 6 times 3, 6 times 4. Multiples you multiply to get bigger. And actually, in elementary school, you probably called this skip counting. If you look back at one of your first grade report cards, it might say skip counting. And then it has a little E by it for excellent or whatever it is. So multiples, you multiply to get them, or you might also call it skip counting. Now the learning target said we want to be able to find the least common multiple, 2 or more numbers, or expressions have in common. Why did I add that expression in there? Because that includes variables, of course. Get excited. So when you're skip counting 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, you can see they have several multiples in common. But we want to find the smallest one. Now, one dilemma is that we just finished using a whole bunch of factors, so people confuse the least common multiple with greatest common factor. But what's the problem with greatest common multiple? The problem is where does the multiple end? It doesn't, it's infinite multiples. So we are instead finding the least common multiple, the smallest one they have in common. So the least common multiple of 4 and 6 is 12. Another common mistake is that people use this strategy to find it. I know, I'll just multiply 4 times 6, which is 24, and now I just found the least common multiple. That actually is not a strategy that works consistently. It works sometimes, but it is not your go-to strategy. First go-to strategy is to make a list to find the smallest one. In the first 3 boxes, that is going to be our goal. Make a list to find the smallest one. So for these first 3 boxes, we're going to make a list. How do I make a list? 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. Where do I stop? Good question. I do a handful, 5 or 6, and then I move on to the other number, and I might have to go back to the first one. We'll find out. 16 times 1, 16 times 2. Oh no, I don't know 16 times 3. Here's what I mean. I might have to go back to the first one because I've already passed up my list for the first one. So I'm going to have to go back and do some more. 6 times 7, 6 times 8. There it is! The smallest one they have in common. Go ahead and pause so you can do B and C. Pause and work. Oh boy, that list got kind of long. I'm doing this one first because I already have the numbers from part B. Oh, these numbers are getting big. Do you see these numbers, how big they're getting? I didn't even find a least common multiple yet. Oh, I don't know my 18s. I'm going to need a side problem. Oh, I was hoping it was going to be 60. Were you hoping it was going to be 60? I don't think it's going to be 60. Of course, 12 has a 72, but 15 doesn't have a 72. Of course. Of course, 15 has a 90, but 12 doesn't have a 90. Of course. How long is this going to go? How long is this going to go? You know what usually happens by now? 7th graders do this thing called give up. I don't know why they would want to give up, but they do. Which is why we might sometimes need a different option, which is strategy 2. Strategy 2, prime factorization. Are you ready? Again, for some problems, it might go faster because we're pretty good at factor trees at this point. So I broke 12 up into 2 squared times 3 times x. 15 is 3 times 5 times x times y. Now, the one thing we need to know about this is how do we know which one to pick? Pick the biggest of every base. What's a base? 2, 3, x, 3, 5, x, y. Those are all bases. So what 2 is bigger than 2 squared? Oh, there are none. What 3 is bigger than 3? This 3 or this 3? Yep, both the same. Doesn't matter. Literally pick one and not the other. What 5 is bigger than regular 5? Pick one, not the other. Which x is bigger than regular x? They're the same. What's bigger than regular y? Nothing, just y. So now I'm going to multiply that all back together. Where did I get 60? 4 times 3 times 5. Next one, prime factorization. So I broke 8 up into 2 to the third. 14 is worth 2 times 7. What's bigger, 2 to the third or regular 2? 2 to the third. What's bigger, 7 or... Oh, there are no other 7s. That's automatically the biggest. What's bigger, m to the second or m to the fourth? Two to the third times 7 times m to the fourth. Go ahead and stop here and try to find the last one. What's bigger? Regular 3 or... Oh, there is only one 3. What's bigger, regular 5 or 5 squared? 5 squared. What's bigger, y squared or? That's it. What's bigger, x or? Three times 5 squared times x times y squared. Don't forget this when we talked about exponents earlier. The variables should be least to greatest. Now, why did we do that prime factorization way? Because this one over here, we never actually solved. I wasn't finding a least common multiple when I was skip counting, so I thought there has to be another way. Here's my other way. What's bigger, 2 or 2 to the second? 2 to the second. What's bigger, 3 or 3? Literally doesn't matter, pick one, they're the same. Oh no. I see another 3 bigger down here. Oh, good thing I caught that. And then what's bigger, 5 or no other 5s? 2 squared times 3 squared times 5. 120? I didn't even have, oh, not 120. 180. Oh, my list wasn't even long enough. That was a long list. So remember, you have this prime factorization backup method if your skip counting isn't going well. For smaller numbers, skip counting is probably fine. For bigger numbers or longer rows of making a list, consider using the prime factorization. Both options are going to be fine when you switch to the problems for today. Good luck, people.